Welcome back to the Deep Dive. Okay, today we're diving into something that, well, it might seem a bit dense at first glance, but honestly, it's absolutely foundational, especially, if you're prepping hard for those ATPL theory exams. We're talking about the real power behind the scenes in an aircraft. Hydraulic systems. When you picture a plane, right, your mind probably goes straight to the engines, maybe the wings or the cockpit, but kind of hidden away, there's this incredibly complex network. Fluid, pipes, pumps, and this system, it's basically the muscle. It's doing the heavy lifting for so many critical things. We're talking landing gear, huge things, flaps, flight controls, brakes, even windshield wipers sometimes. And what makes hydraulics the go-to for this stuff in aviation is, well, you get massive power, really accurate control, and it responds super fast. So our mission today, cut through that complexity. We want to pull out the really vital bits of knowledge, the stuff that'll give you a real edge in your ATPL studies. We got a whole stack of your questions here, and we're going to, unpack them, build up a really solid understanding.
And joining me, as always, is our resident expert, ready to connect the dots and give us that crucial why does this actually matter?
Yeah, that's exactly right. Hydraulic systems, they really are the mechanical muscles of the aircraft. They make incredible engineering feats possible. Think about it, tiny adjustments to control surfaces way up high, but also the brute force needed for braking when you land. And understanding them, it's not just about memorizing parts lists or, dry facts. It's about grasping the principles, the things that make flight possible, and crucially safe. So yeah, we'll definitely focus on the concepts, the applications that pop up frequently in the exams. Make sure you're not just sort of informed, but genuinely ready to tackle those questions.
All right, let's unpack this core concept then, the thing that underpins everything. Pressure. We hear hydraulic pressure thrown around all the time. But what is it exactly? And how do planes actually generate it? And I know Pascal's law is absolutely key here. What does it actually state and why is it so vital?
Great place to start. Okay, first, let's touch on hydrostatic pressure. Just imagine any open container with fluid in it. The pressure down at the bottom. It only depends on the height of the fluid above that point. Doesn't matter if the container is wide or narrow. Same height, same pressure at the base. Simple idea, but it's a starting point. Now, the real magic for aircraft hydraulics comes from Pascal's law. Blaise Pascal, way back when. He figured out that, essentially, if a force is applied to a liquid in a confined space, then this force will be felt equally in all directions. That right there, that's the absolute cornerstone. Think about how powerful that is. You push on the fluid here, and that force is transmitted everywhere inside that closed system, instantly.
Equally in all directions.
Exactly.
Yeah.
And it means you can amplify force. A small push on a small piston can create a huge force on a larger piston somewhere else in the system. That's the mechanical advantage that lets pilots move massive things with relatively little effort.
That's a really critical distinction then.
Yeah.
The idea that the force is felt equally everywhere. So if I'm getting this right, the pump itself isn't actually creating the pressure on its own. It's more about the system resisting the flow.
Precisely. That's a fantastic way to put it, and it trips people up sometimes. So it's really vital for your ATPL understanding. The pump. It provides the flow, gallons per minute, liters per second, whatever. But the pressure, that only gets created when that moving fluid meets some kind of resistance. When you try to essentially compress it, even though liquids don't really compress much, think about it, pushing oil through a totally open pipe. No resistance, no pressure.
Right.
But the second you put a blockage in, maybe a valve closes or an actuator hits its stop, or it's just pushing against a heavy load like the landing gear, bam, pressure builds up instantly. So the key takeaway, no restriction, no pressure. It's all about that resistance in a confined space.
Okay, this is where it gets really practical, exam-like. Let's put Pascal's law into action. We've got a question here, typical sort of thing you might see. Question 1. You apply a force of 100 newtons to two separate jacks. One has an area of 0.02 square meters, the other 0.04 square meters. What's the pressure exerted by each jack? Can you walk us through that?
Absolutely. The formula we need here is fundamental. Pressure equals force area. Simple but powerful. So for that first jack, the one with the 0.02 meters.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.